Hello, you are welcome once again. Today we want to find the possible value of x, given that you have x to the power of 6 equals 9 to the power of x. So guys, let's have it to the solution. Now from here we have x to the power of 6 equals 9 to the power of x. Now from here we have x to the power of 6, but we can simplify 6 as 3 times 2 equals, we have 9 here, we can also have it to be in base 3 as 3 to the power of 2, then to the power of x. Now by applying the law of indices, that says when you have a to the power of m times n, you can simplify this as a to the power of m, all in bracket, to the power of n. And likewise, when you have a to the power of m, then to the power of n, we can rearrange the power of this as a to the power of n, then to the power of m. So by applying these two expressions that we have here, let's apply this one here, and let us apply this one here. So this implies that we are going to have x to the power of 3, then to the power of 2 equals 3 to the power of x in bracket, then all to the power of 2. Now from here, we can do something reasonable. When we try to introduce square roots, we have here to be square root of x to the power of 3 in bracket to the power of 2, then equals square root of 3 to the power of x, then in bracket to the power of 2. Obviously, this we cancel this. Then we have x to the power of 3 equals, this we also cancel this. We have 3 to the power of x. So we have this to be equal to this. Now let us introduce ln natural log to both sides of this expression. So this implies we have ln of x to the power of 3 equals ln of 3 to the power of x. So by applying the law of natural log, this will come down to the base. We have 3 ln of x equals x ln of 3. So now guys, so from here we can divide through by x. When we divide this one also by x, so we have 3 ln of x, then divided by x equals, this we cancel this, we have ln of 3. Likewise, we can divide this one by 3. So we have this to cancel this, we have ln of x divided by x equals ln of 3, then divided by 3. Now, from here, we can actually have this as ln of x, then multiply by x to the power of minus 1, then equals ln of 3, then divided by 3. But according to law of logarithm, when you have e to the power of ln of a, this will give you back your a. By simply apply that here, it implies that we have e to the power of ln of x to the power of minus 1. This will also give us back our s to the power of minus 1. Now, so we can now have this as ln of x, then e to the power of, instead of writing this one, we replace it with this as e ln of x dot e to the power of ln of x to the power of minus 1 equals ln of 3 then divided by 3. So therefore, guys, from here we have ln of x dot this negative minus 1, we come here, we have dot e to the power of minus ln of x then equals ln of 3 divided by 3. Now let us try to have or to make sure that the base here is equivalent to the power that we have here. So what we can do is to multiply by negative here. The moment when we multiply this one by negative, we have here to be ln of x, then e to the power of l minus ln of x equals, we are multiplying through by negative, so it will affect this as well as minus ln of 3 then divided by 3. So having known this one, we can take note of this expression. We want to apply something we call Lambert W function. Now, by applying Lambert W function, that says when you have the Lambert W function of fish, then multiply by e, the exponent, to the power of fish, then according to Lambert W function, the output will be equals fish. Now, what the Lambert W function trying to say is that anytime when you take the Lambert W function of fish that also multiply by the exponent raised to the power of fish, the output will be equals fish. So far the base and the power are the same, the output will be either of the one. And by applying it here, because we also have, there's a connection of exponent, we also have exponent here, and the base and the power are the same also. So we have here to be Lambert W function of minus ln of x e to the power of minus ln of x equals W Lambert function of the right hand side minus ln of 3 divided by 3. So according to Lambert W function, here will also be minus ln of x equals W Lambert function of minus ln of 3 then divided by 3. So from here, we can also have this as ln of s to the power of minus 1 equals Lambert W function of minus ln of 3 then divided by 3. So from here, when we take the exponent of both sides, this will cancel this. We have s to the power of minus 1 equals e to the power of w, e to the power of Lambert W function of minus ln of 3 then divided by 3. Now, from here we have our x to be equals 1 divided by e to the power of Lambert W function of minus ln of 3 divided by 3. So now when you compute this, because we're going to have this as minus 3, then the Lambert W function of minus ln of 3 divided by 3, then divided by ln of 3. The expression that we use to get this one is when you have e to the power of fish, we give you fish divided by W Lambert function of fish. So when you apply this expression, you are going to get this. And we have the 6 solutions of x. We can have s1 to be equals minus 0.7577. We have x2 to be equals 2.4781. We have our x3 to be equals 2.9999. Then we have our s4 to be equals minus 0.5529. And if you are new here and you find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more mathematics tutorial videos. Bye bye. See you in the next video.